Hey everybody, Lars here. You don't know because I deleted it all, but I started this video and was a little bit into it. And then my buddy showed up, my buddy Daryl, and he showed up because I am the one who holds the season tickets to Rutgers football. And I cannot go tomorrow because I have a gimpy leg and it's breaking my heart. Because it's going to be a good night. Tomorrow night at 8 o'clock we play Michigan. And it's a big game, big team. They are going to spank us. Anyway, striping the birthplace with everybody having different colored shirts on, black and red, so everything should be cool. It's a night game. Should be a good time. But Mr. Achilles cannot go, which is not that big a deal. I got to watch it on TV, and I'll be able to see it all. But I had to give my buddy his tickets, and I sent him a text. I said, hey, don't, if you come in quietly because I'm making videos. He didn't even look at the text. Bam, came crashing into the house, making a whole ruckus. So anyway, that's over with now. So now, finally, I can sit down calmly, quietly, and put together review video number 1 for Unit 3. And I know I've talked about Unit 3 like it's the scariest thing on earth, but it's not the scariest thing on earth. The thing with Unit 3 is that there's a lot to it. It's a 3-week unit. The 3 different sections of this particular unit break down nicely into 3 equal parts. So I basically do a review video for each one. If you spent like the first week with functions and then the next week with file IO and then maybe front load the library one a little bit so you have some time to work on the assignment, it'd probably be a good way to handle it. I know you've heard me say it a million times before, but engage with these resources early. If you read the slides and you read the Zell over this coming weekend, so you have the lay of the land as far as this stuff is concerned, you will be so far ahead of the game, it will be ridiculous. So, because you'll know what's coming, and when you get the assignments, I'll try to get you the assignment early too. I never give you the assignments right away because then people go, oh, assignments, blah, blah, and you'll just do what you have to do the assignment. I've always said that's not a good way to learn. I want you to engage with the resources first, play around with some of the exercises, think about it, steep in it. Then the second thing you're going to do is go through the assignments and do the assignments. This one is basically assignment 1. I'm going to ask you to create a function that does a certain thing. And then in assignment 2, what you're going to do is you're going to use that function in the context of the second assignment, and you're going to do so with a little bit of file IO, and you're going to create some libraries, and you're going to do some extra things. It's going to be fun, and it's the one assignment that really puts it all together. Everything you've gone through in the last 5 weeks plus the next 3 weeks of Unit 3, you're going to use all of those skills to put together this final assignment for Unit 3. And you'll see it's fun and it's interesting and it's good. It'll review all the skills that you've been through and stuff like that. But I digress. We need to look at the first part of Unit 3, and that is functions. I am already over the Mets, in case anybody was curious about that. Familia has got to go. That was just a mess. If anyone's old enough to remember Armando Benitez, I was having flashbacks the other night. Whew. Shows how good Syndergaard was. You notice when they got Syndergaard out of the game, all of a sudden, boom, 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 Giants start hitting like crazy. They hit Reed, they hit Familia. So it showed you how good Noah Syndergaard is. But after that, they just folded like a cheap chair. Like a cheap beach chair, which is fine. The pitching will be healthy next year. Hopefully they get another hitter. I don't know if I want to keep Bruce, but we'll see. We'll come back. Always next year. Always a bridesmaid. Welcome to Metsdom. All right, enough of this garbage. Let's look at, I already created a little shell for us to use, functions.py. And the first thing I'm going to start out with is I am going to create a little list for us. Good enough. Oh, let's use brackets and not braces. 3 times a charm. And then what I'm going to do is I'm going to use a function on it. Watch this. There we go. Let's get our output window near our programming window so this can all make sense on the video. All right. You've probably known it all along because I know Zell mentions functions right away, but we've been using functions all along. Python has a group of functions that are built into it. You're going to see later in the third part of the unit that it also has a standard library. We can import functions to do a lot of that functionality, but there's also a group of functions that are built in and ready for you to use already. One of those is sum, and you can see that idle turned it purple. And what sum does is if you give it an iterable, it's, something that holds integers or floats or something like that, it will sum up everything in the list. And as you can see here, it summed them up to 30, 2, 4, 6, correct, 30. So we've seen that in action already. And as far as the anatomy of a function is concerned, a function has a name, which in this case is sum. A function will have an argument list. This is optional. Some functions don't have them, like the little function I wrote you in the slides that print the first 4 lines of Detroit Rock City. But this one does, and what it does is this function takes as an argument a list or any iterable. And the return is over here, the 30, the value. We print the return value here. We're going to talk about that in a little bit. So that's basically how that function works. Another function that you've already seen is type, because we did some stuff with that with our data in the first unit. And as you can see, this is a list. We're going to learn what a class is and know what that's all about come Unit 5. Right now, just know that it tells you that the object you were looking at was a list. If we did it for an integer, it would be an integer, blah, 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 blah. So that's another built-in function type. And if you want to go look at the function types, hold on, I think I have this up already somewhere over here. NJ.com is bad, is it? NJ.com is terrible. When you load it and start reading something, all of a sudden different advertisements load and text moves around and you can't even do it. And then they have the phony advertising. Do they have one of those? Look, sponsored content. They make it look like it's news, and it's really a commercial. They are the worst. They are just awful. Get off my screen. Go to the Python documentation and just come in here. See, I already did it. To test. And just hit built-in functions, search results. Of course it doesn't match any documents. Why would that not match documents? Built-in functions, I do it that way. Built-in functions, and boom, there we go. You can see a list of all the built-in functions that Python has. The thing about these functions is that they're ready to go. Okay? When you load Python up, these functions are automatically loaded. They're what's called the built-ins, and they're ready for you to use, okay? Do not use eval. We've been through that. But you can see sum is here, and POW power does power, and we're going to talk about open when we do files and a whole bunch of other things. So here in the Python documentation, which is your best friend, by the way, we're going to look at it a whole bunch of times. You can get explanations of what these different things do, like we use int to do casting. Click on it, and it'll tell you exactly what it does. It returns an integer constructed from a number or a string or blah, blah, blah. It will tell you exactly what it does. So if we were to click on sum, you can see that sum sums up the terms of an iterable from left to right and returns the total, boom, boom, boom. So the built-in functions are all there. You can look at them in the documentation. As you're going to see, we'll just go to the documentation. This documentation online is fantastic. It's like the instructions. It's like the instruction manual that would come with Python, but there's a tutorial later. In the third part, we're going to talk about the Python standard library. You can see all of this pre-written code that's sitting there for you to use. It's really cool. You can read. There's how-tos, there's FAQs, there's a whole bunch of different things. So just go to Google and type in Python docs, and boom, you'll get the documentation. I got the latest and the greatest. If you're using an older version, you can go click on that older version, and that'll be there too. Okay? So definitely, if you need to use that documentation, it is good. That's all well and good as far as explaining what a function is, but the more important part is showing us how to write our own functions. And what I'm going to do really quick is write a function called multicube. What it's going to do is it's going to take 2 integers as an argument, and I'm going to multiply those integers together, and then I'm going to cube the result and send that back and print it. All right, so first thing I'm going to do is I'm going to type DEF. You can see that idle made it orange, and that basically stands for definition or define. We're telling Python, hey, we're about to define a function here, okay? So don't do anything. Just take the function that we give you and put it in memory and wait for us to use it. So I'm going to give it a name. I'm going to call it multicube. And I'm going to take two parameters, two variable names, which are A and B. Then I'm going to give it a colon because I want to start a block, and everything in that block is going to be part of my function. So idle will indent 4 for me. So now I have A and B as variables, the two different parts of my multiplication. So what do I want to do? I'm going to create a variable called z, and I'm going to make z equal to A times B. Then I'm going to return z, but I'm going to cube it. And that's it. You'll notice when I hit enter at the end of return, it took me all the way back to the side. That's because when you hit return, idle figures, okay, you're done with your function, you're sending a return value. So it will automatically bump you back out to the regular level, which is pretty cool. Idle's all right. Okay, so now we have a function. Okay, it's defined as the name multicube. The arguments are A and B, and the return value will be z cubed. We create z here. Okay, remember, we evaluate expressions from right to left. So B is defined, A is defined. We're fine. We don't have to set z equal to 0 or anything like that. It can get its initial value from these guys because these guys have already been spoken for. Okay, and then just real easy right here, we're just going to print multicube 3, 2. 3, 3, 3, 3, 2, 3, 2. All right. And that should give us, what does it give us? A times B is 6, 6Q, 216. Yay, and it gives us 216. So that works. Now, we've defined that logic and typed it in already. So now if we wanted to do something else, all we have to do is call multicube again. Now if we did 2, 2, it would do it for 2, 2. Okay, 2 times 2 is 4. 4 by 4 is 16. 16 by 4 is 64. So we got it. Okay? So if we trace through this, okay, just go back to the regular one again, we'll see that comment, ignore it. This is a string, ignore it. Def says don't run anything. We're just doing a definition. I define my function. Again, my name is multicube. The two arguments are A and B. They're just variable names for use inside the function. I do a colon to create a block because that block is going to be my function. And then I just start doing commands and doing the logic that I want to do. I create a variable called z and I make it equal to the product. And then I just take the product and cube it. So I multiply, then I cube. Okay. So then I return z cubed. Okay. Now, down here in this particular program, it's funny because the first thing that really gets executed is the very last line. I want to print to the screen the return value of multicube 3, 2. So what happens here? I go up to multicube. A becomes 3. B becomes 2. So z equals 3 times 2, which is 6. So now z is 6. Then I return 6 cubed. 6 by 6 is 36. 36 by 6 is 216. And that's what we see over here, our 216. Okay. Now this return returns that value to the calling function. So it's almost like this calling function becomes a variable name at this point, and it holds the value 216, which is then printed to the screen with our print, and then the program ends. Okay. So that's very simply the simple definition or anatomy of a function. You have a name, you have arguments, which are optional. If you want to just set off a block of commands that you run off to the side, then you can do that too. But most of the time when we do our functions, we have arguments or things that they use inside the function in their logic. And then here we happen to have a return value, so we return a value. We're going to talk about that in a second because there are two things we really want to talk about when we talk about functions. The first is something that is called scope, and that's real easy to talk about in this context. Print z. What do you think will happen if I try to print z here? Z is up here. It's kind of a temporary variable that we use to hold the product before we cubed it and then returned it, okay? It's right there. It's in our code. What will happen if I try to print z? It blows up, and it says name z is not defined, okay? Z, as far as this program is concerned, doesn't exist anymore at this point in the program. It's because of a concept in programming called scope. When we come down here, and we're about to execute our first line of code here, we're in a big memory space that programmers call global space, okay? Global memory space, everything can see everything else, everything's good. But here, when we call multicube, we are running a function. That function right up here goes and grabs another section of memory. We call it local space, and it runs itself, and then it returns the value, and then it disappears. It's almost like a bubble. It creates the bubble, it does all the work it has to do in memory, and then it returns the value, and bloop, it's gone. The analogy I always use is like scratch work when you used to take a math test. You would need an answer, you'd come here, you'd do your scratch work up here, blah, 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 but when you hand the quiz in, you only hand in the answer. Scratch work is gone. Think about it that way. So, after I get the return value, 216, and I print it, all of this is gone. So the program at this point doesn't know what z is. So if I try to print z, it's gone because it was a local variable in the function, and right now all of that's out of memory and all of that is gone. Now, if I wanted to print z, if I was really hard-pressed to print silly z, I could do it here. Let me get rid of this so we actually run. And there, you see the 6 right there. That's fine, because I could refer to z while I'm in local space, and I'm doing that work in local. But if I come out when the function is over, there is no more z. Just like there would be no more a and no more b. Everything that was going on in this function doesn't exist when we get back out, okay? Because it's local. So you have to understand the concept when you're dealing with functions of global scope and local scope. When you're doing things in a function, you're doing things locally. When you come back out, none of that's going to be able to be referenced or be able to be used, okay? So there's one last thing that we have to review, basically, when it comes to functions. And we are going to rerun our code, and we're going to rerun our code just like this, okay? 6. Let me zods that out and rerun. Okay, nothing happened. Now, there's no error, okay? Our code ran, and it ran error-free, but just nothing happened. Nothing was printed out, and nothing was done. This is an example of not capturing the value of a fruitful function. If you recall from reading the slides, hopefully you've read them already. I know I'm going to get you this video super early. So some of you might, be video crazy and be watching the video before you read the slides. Don't do it. Read the slides first. Anyway, I got a function there, and I went and I ran it, but I didn't print it to the screen, or I didn't save it to a variable. So it's now gone. Things don't automatically print. I could put a print statement in the function if I wanted to do something along those lines. You've seen that behavior in the slides. But what I really want to make sure I do when I have a function that's what's called fruitful, which means it returns a value, because I return a value here. I return z cubed, is I want to save it. I want to save it to a variable. Now, before I was just printing it, which is fine if you only need to see it once. But most of the time, you'll save it to a variable. That way, you have it. When you run things, now you can print it out and everything's back. But once you've saved it to a variable, then you have it. And, as many times as you want, you can print it out and do whatever you want with it. So most of the times you'd save it. Be wary of capturing the values of fruitful functions. Because as you see, when you read through the slides and you did all that, you have void functions, which like we used when we just printed lines to the screen. But you also have fruitful functions. When you know a value is coming back, you have to make sure to capture it. Either print it out if you only want to print it out once, or save it to a variable. In this case, I saved the value of multicube 32 to C, and now I have it to print, and I have it to do things with. I could use it in other logic later in the program or whatever, okay? So be aware of those two things when we're dealing with functions. Be aware of scope. When I've done with my function, it goes the way of the dinosaur. It's out of there. So when I come back out with my return value, I can't reference any of the variable names or anything that was going on in that function because it's gone. It's out of memory. it was scratch work. All right, see you later, bye. And the second thing we want to do is that if we have a fruitful function, if we have something that returns a value, we want to make sure we capture it. At the very least, we want to make sure we print it. But it's probably better to assign it to a variable, and then the variable can capture that value. And then we have the variable in memory in global space for us to use and do whatever we want with. Okay? So I'm going to get rid of this, and I'm going to get rid of this, and I'm going to save this, and I will put func.py up on Sakai for you guys. There is one last thing that we're going to do real quick in this particular video. And I created a shell for that too. Let's see up here. We are going to revisit. Do I need that? Let me do this. Well, that doesn't help any because it's still down there. Whatever. All right. Go back and think about Euler 6. Euler 6 was a program that we had to take the square of the sums, or the sum of the squares from 1 to 100 and find the difference between that and the sum of the squares, or the square of the sums. I get them both mixed up. And basically print out the difference. And we tackled this problem last unit when we had simple arithmetic and lists and sequences and iteration and looping. We had all that stuff under our belt. So we tackled that problem with those tools. But now we have functions. Okay? So now we can rewrite the Euler 6 solution, at least to my mind, in a little more compartmentalized, easier to understand way. So let's say, and I'm not going to go look at it. I know I have it up too. Let's say we want to create a function to find the sum of the squares. So I'm going to call it SOSQ. I will take n as a limit. And what do I want to do here? I want to make s equal to 0. And then I want to say for I in range 1, because I want to start at 1, to n plus 1, because that's the first thing I don't want. I want to make s equal to s plus, and I want the sum of the squares, yes? So I'm going to take I, squared. Done. Let's test it. I'm going to print sum of square, 10. We'll do 10 first, because I think I remember the answer to that. And if I save it and I run it, it says none. Uh-oh. Dun, 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 dun. Sum of square n. Hey, how about returning something? Dun, 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 dun. That was a nice little error. If you do not return and you try to print something, a void function will return a value, but the value will say none. Okay? You want to make sure you have a return. In my case, I want to return s. I think now I'm going to be okay. And now I return only 1. What is going on here? For that, s equals s plus I for I in range 1 to n. S squared, return s. Oh, yeah, how about putting it outside of the loop? So we go through the loop first before we return it. Woof! I have brain drain today. Goodness gracious. Look at that, 385. So that, if memory serves, is the proper answer for that particular thing. Woof! Goodness me, I got to get going here. I got to get my brain keyed in. All right, so I've tested that. Now what I'm going to do, what every good programmer does, and I'm going to cut and paste a little bit. I'm going to copy that, and then I'm going to paste there. And what I'm going to do here is I'm going to create one for square of the sum. Not a lot of what we're doing is the same, so I don't want that. I want that, yeah? So now for the square of the sum, what I want to do is I want to add all those numbers up, and when I finally get that final thing, I want to square it. So that's the square of the sum. So now I'm going to print sum of square for 10 and square of sum for 10. Somewhat confusing names, but that's okay. And I get 385 and then 3025, and I think that is actually correct. I think that is correct. Now, What I really want to do at the end of the day is find the difference, yeah? So print the diff is colon, comma, SQOS 10 minus SO SQ 10, and look at that, 2640. Memory serves that is the answer to their little test that they had. We really want the answers for 100. So actually, you know what? Because I'm a good doobie, I'm going to go limit equals 100. And then in here, I'm just going to do limit. And we will use variables. So now, if it's 10, it should give me the same answer. It does exactly the same, but now with only one change, I can save, rerun, and 25, 164, 150. That looks good to me. Okay, don't get freaked out by the colors. This is my Euler. I'm logged in as myself, so I mess with colors and all that nonsense. Archives, problem archives. Oh, I'm not logged in anymore. They logged me out. So, so what do I have to do? It's not going to show me the answer. I will log back in. 35588, because I'm not a bot. So I sign back in as myself, and I go back to the archives, and you can see my Euler. See, I got all check marks because I've done all the first 50 Eulers. So you can see check marks next to all of mine. But if I go click on 6, you'll see that I did this one in August 2014, and the answer is indeed 25164,150, which is what we got when we did it over here, 65164,150. So that is correct. So take a look at the solution, okay? My programmer brain tells me that that's a better way to tackle the problem than the way we tackled it the first go round, because we took our knowledge and we compartmentalized it. I have a function here that does the sum of the square. I have a function here that does the square of the sum. Now, basically, it's 2 lines. It's 2 lines because I don't need this silliness right here. So when I run this and I get the answer, it's 2 lines of code. I set the limit, and then I just do the difference in the print statement. You know, there's no reason to go nuts with that. Okay, so one thing that's important about this in the way that we did it is that, and you'll see this in the third part of this unit, is sum of square, square of sum. I got that problem licked right now. I could take this function, put it in a library, and always have it for the rest of my life. For the rest of the time I'm a Python programmer, I got that problem licked. It's fairly general enough that I could see it being used. You know, go up to a limit and square the sum from that limit all the way down to 0. I mean, that might be needed at some point in time. So now I have that logic, and it's all sitting there. So if I took this and I put it in a library, I would just import these from the library and do these 2 lines. It would literally be a 3-line program to solve this problem. So this kind of, Euler 6 works well as far as showing you how you take a big problem and compartmentalize things. So the first thing we're going to do is we're going to grab that sum of the square. And I actually wrote a function just to do that. And then I want to get the square of the sum, and I wrote a function just to do that. And then down here, I just used my 2 functions. Found their difference, and boom, I was off to the races. Okay, set the limit here. You don't have to be honest. I mean, I could get rid of that limit and just hard code hundreds in there, and then you'd be solving things in 1 line. Okay, so this has always, to me, seemed like a much more efficient way to do this. Maybe later in the course, we'll look at a concept called list comprehensions, and I will show you that, to be honest, you could do this entire program in 1 line and just basically do your loops and do your calculations inside of your, print statement. But that's ahead of us, and you're learning, and you need to learn all of this stuff, so forget about that for the time being. But this, to me, is a understandable, compartmentalized, good programmer approach to doing this particular thing. I remember back in the day, you would create all your functions and do all your constants and do all that, and then you would put main program, and then you would have all your different commands that you would run. Sometimes some people will call it the driver part of the program, and you would run your commands from there. And at the end of the day, once we've done all our definitions, we only have 2 lines of code because we're using what we defined up there. Okay? So, as always, you don't have to worry about Euler 6 with functions, which is where that gets its name from. I, too, will put that up on Sakai, and you will be ready to rock and roll and play around with it and to do some different things. And as you attack the Euler problems, as some people in the class have been doing, it's been really cool if you ask me. Think about using functions when you look to solve your problems. You don't have to, but later on you'll see it becomes a necessity almost later, and it helps you to understand things, because when you get to the point where you're loading code from the standard library and you actually want to go and see what that code is doing, that's all written in functions. And later you're going to see that oftentimes functions, which are part of classes, are called methods, and you can go read the methods or you can go read the functions. That you will get to all that. Don't let that freak you out at all. Just take a look at this, and I'll put func.py up in Sakai, and I'll put this up in Sakai. All right? All right, good. Then we are done. Announcements. I don't want to kill you with announcements right now because we just got done with Unit 2. Everybody did, from what I can tell, everybody did good at Unit 2. The quizzes looked okay. I saw the bunch of 3s, bunch of 4s, bunch of 5s. So once I grade them, and I have to grade that short piece of code at the end myself, those are going to turn into a bunch of 5s, a bunch of 6s, a bunch of 7s. So hopefully I'll have some time to tackle that over the weekend, and you will be able to get your grades for Unit 2 a whole lot quicker than you did last time, because last time you had to deal with the second round of Mr. Achilles. So that slowed Hans and I up as far as getting you grades back really soon. You have your readings for Zell. You have your slides. You have video 1 now, okay? Over the weekend, because I'm doing this Friday night, over the weekend, I will do video 2. And then probably Monday, I'll release video 2 for you. Then later in the week, maybe Tuesday or Wednesday, I want to give you 5 or 6 days with the resources before I give you the assignment. Then I will hit you with the assignment. And because I want you to have it a little bit early. It's a long unit. It doesn't end until October 27th, which is 20 days from now, 21 days from when I'm recording this. So it seems like a lot of time, but please, please, I know I'm a broken record. Engage with the resources as early as possible so that you do not get bit in the rear end and you are not sitting 2 nights before saying, oh my God, I'm not going to be able to do this. I don't want that to happen to you. Engage with those. Just read the slides. If you just read the slides in the first day or 2 of this unit, you will be golden, because you'll have all the concepts in your mind. You'll kind of know what to expect and what's going to happen. And like I said, the unit breaks down nicely into functions, and then the second part is file I/O. I/O means input-output, if you're confused on that one. And then the other part is libraries, modularity and libraries, where you're actually taking these functions and you're going to put them in separate files. And you're going to be able to use them in your code from separate files. So they don't even have to be sitting there on the screen, cluttering things up. Okay? That's when the rubber really hits the road. That's what professional programmers do. And you're going to see how to do that because you are on your way to becoming a professional programmer. I will see to it. Okay? So don't worry. All that good stuff is on the way. Part of me wants you to read the slides this weekend. Part of me wants to tell you to take a break because it's been a month and you deserve it. And everybody's doing very well. You guys are a good bunch. So I don't know. The doofus programmer part of me is going to tell you to take a little bit of a break. The angry professor part of me is going to tell you to read your slides over the weekend and code every day. And gosh darn it. All right. So I don't know. If you got nothing to do and you got a half hour you want to kill, go look at the slides. See what it's about. Get going on this stuff. Because at the end of the day, it's fun. It's solving puzzles. At least it is for me. And that's why I ended up being, before I went back to academia 12, 14 years ago, I was a professional programmer for 10 years. I was out in the real world actually writing code. And the whole reason I did it was because to me, it was like puzzle solving. You know, you have one big puzzle and you got to take it apart and make different functions to solve different parts and then hook it all together to make it work. Believe me, some programs are like Rube Goldberg devices that you don't think they're going to work and they end up working and boom, boom, boom. And it's a higher level of puzzle solving, taking your logic and codifying it and then reusing it in different situations and doing things like that. It's fun. That's why I always liked it. So I want to teach you how to do all of this stuff, but I also somehow want to convey that it's fun. And it was fun for me, and I'm guessing it's fun for a lot of you too. Whenever you finally think you have it and you run that program and you get that answer and you're like, the thing finally did what I told it to do. It's a buzz. It's a good feeling. And even an old fuddy-duddy like me, I've been programming for 35 years, I still get that feeling when something works. And you're like, yeah, good. Finally. Thank God. So keep doing what you're doing. This is a good class, and you guys are doing good. All right? So I'm going to leave you now. And you know me. I'm going to hit you with announcements, and you will be well informed of all the things that are coming up and all the things that are going on. All right? You have a good night, and I will talk to you soon. Bye.